Hi all, welcome to Unit 1 Physiology. Just a quick lesson on the oxygen dissociation curve and the Bohr shift and some good memory hooks to remember the processes. So a memory hook that we have looked at previously for the oxygen dissociation curve is Dr. Taco. So a good way to remember exactly why the curve is shifting to the right and the processes involved. So if we remember Dr. Taco, we know that the Doctor stands for dissociation curve and the R stands for right, okay? The Bohr shift means that it shifts to the right, okay? So in your exam, you would be awarded 1 mark if you were to refer to the curve shifting right and the name of that curve, the oxygen dissociation curve known as the Bohr shift, okay? So the reasons why it shifts to the right are also encompassed within this memory hook as well. So we now have the T, that represents temperature increases in blood and muscle tissue. That is one cause of that shift to the right. Our second cause would be acidity, increases in blood and muscle tissue. So that's the A within Dr. Taco. That signifies a cause of why the curve shifts to the right. And then C, carbon dioxide has a steeper diffusion gradient between blood and muscle tissue. That is a cause of why it shifts to the right. And finally, oxygen has a steeper diffusion gradient between blood and muscle tissue as well. Okay, so the 3 causes of the Bohr shift, the 3 reasons why the curve shifts to the right, is an increase in temperature, a decrease in pH, which means acidity has increased, so that's the A, and carbon dioxide, okay, an increase in carbon dioxide, okay. So it is important that we also know what affinity is. So affinity means a liking for something, we want it, we must have it, okay, it's the connection, the relationship. So if we've got high affinity, that means we are holding on to oxygen, okay. If we've got low affinity, that means we do not want to hold on to oxygen, we're trying to release and let it go. Okay, so as we move through the oxygen dissociation curve, affinity is reduced, and I'll explain that using a graph in 1 moment. So Dr. Taco is the important memory hook here. So the curve itself then. So when we see the oxygen dissociation curve, it is almost a backwards S shape. So this green line represents the oxygen dissociation curve. So at the top of the curve, that represents our lungs, and at the bottom it's representing our muscles and our tissues. Okay. So on the y-axis we have the percentage of oxygen present, so the oxygen saturation, and on the x-axis at the very bottom, that is the pressure of oxygen. Okay, so at the very top of the curve, there's lots of oxygen in the lungs. Hemoglobin is kept tight hold, so there is high affinity in the lungs, okay, we're holding on to that oxygen. As we move through the curve, that blood is travelling through the body, and oxygen is present, and it's less as it moves away from the lungs. So as oxygen is moving within the blood along our curve, we are releasing oxygen, offering off oxygen to our resting tissues to help with processes. Okay. Again, if we move further along the curve, when we enter our muscles, there is a low oxygen, okay, so the hemoglobin, and we know that hemoglobin can attach 4 oxygen molecules, it releases oxygen to help make ATP, adenosine triphosphate energy, Okay, so there is a low affinity within our muscles. We want to release the oxygen from the hemoglobin because we want to create energy, and we need oxygen to create energy. Okay, so like I said at the very start, using Dr. Taco, when exercise begins, the curve shifts, okay, and it shifts in the right direction, known as the Bohr shift. Okay, in exercise, demand for oxygen is greater, so tidal volume and frequency increases. All right, and that's where we would see that shift to the right hand side. So your curve may shift from the green line to the left during exercise. Okay, so like I said, remembering that memory hook, the 3 causes of the Bohr shift as we exercise: an increase in blood temperature, an increase in carbon dioxide, and a decrease in pH. So Dr. Taco, we've got T for temperature, okay, A for acidity, that's our 3rd cause here. The decrease in pH means it's more acidic. Okay, and finally we've got that C for an increase in carbon dioxide. Okay, so thinking back, if we just flick back to Dr. Taco, the memory hook, we've got Doctor and then Taco, so that gives us the causes. So finally, in exercise, we know, like we said, that increase in CO2 here on the right hand side in our causes, that causes acidity and high temperature, meaning the speed of oxygen release gets faster, low affinity. So just as a summary then, we have high affinity in the lungs here. That means lots of oxygen in our hemoglobin and we're keeping tight hold of it. As our blood is then released, we then release oxygen and offer it off to our tissues. Okay, so blood travels through the body away from the lungs and we're offering some oxygen to our resting tissues. As we move down the curve then, in the muscle we have low oxygen. Hemoglobin is releasing oxygen to help make energy, and that's within the muscles here. Okay, so that means low affinity. We're releasing oxygen. Okay, so the speed of oxygen release gets faster, and that's due to these 3 causes here of the Bohr shift. Okay, Dr. Taco, to remember that. So some exam questions that you may see. So we've got Ola. Her muscle increases in temperature when she warms up. This causes a shift in the oxygen dissociation curve. State the direction of the shift in the curve and the advantage for Ola when she's exercising. So that direction of the shift, have a think, what would your answer be? Advantage, what would be the advantage of this? And state 1 factor other than a change in muscle temperature. Okay, so we just spoke about this very briefly. The oxygen dissociation curve shifts to the right when we exercise. The advantage of it shifting to the right is that oxygen can be released more readily to the muscles, more oxygen to the muscles. So like I said, that low affinity means we're releasing energy into our muscles to allow to continue for exercise, and therefore reducing fatigue as well. This final question here, C, state 1 factor other than change in muscle temperature. This is when you should be recalling that memory hook, Dr. Taco. Okay, if I've got T, that's temperature, A, acidity. Right, if I've got acidity, that means a low pH. So a change in pH or a low pH would cause a shift. And that final factor, we've got T, A, C, C, high levels of carbon dioxide. That means or results in that shift as well. Okay, so that is the end of the lesson. Don't forget that memory hook, Dr. Taco.